Okay, nomenclature. This is an easy unit. This is just going to be a quick review. You need to know the difference between cations and anions. Cations being positive ions like metallic ions, anions are negative ions, non-metallic ions. Polyatomic ions, you have those memorized. You need to be able to recognize the difference between ionic and covalent compounds. Remember, an ionic compound is a metal and a nonmetal covalent to nonmetals. You need to be able to name and write formulas for both ionic compounds, covalent compounds, and acids. And we'll get to oxidation numbers in just a little bit. So, for right now, nomenclature, if you'll remember, is just naming chemical compounds. There's three types of compounds: ionic, covalent, and alloys, metallic alloys. We're not going to spend too much time on those. Ionic compounds are metals and nonmetals, so you have opposite charges attracting, cations and anions. Covalent compounds are two nonmetals sharing electrons, and then alloys are metals and metals. On the periodic table, you should know this fairly well. Right here we've got the staircase, and the staircase separates the nonmetals over here and the metals on the left-hand side. Of course, hydrogen is also a nonmetal. So we've got metals over here, nonmetals over here. Matter of fact, this group right here, the alkali metals, those all have a charge of +1. Alkaline earth metals have a charge of +2. And then group 3 right here, they all have a charge of +3. These are the transitional metals. That means they're in transition. They can be chromic. They could be copper +1, copper +2. They're in transition, so I'm not going to assign any specific oxidation number or charge. Noble gases, those all have a charge of 0. Halogens, -1. These are the nonmetals over here. These are all going to be -2, -3, and then -4. So that's how you get the charges. Ionic compounds, once again, are a metal and a nonmetal, a positive and a negative. And to name them, you simply say the metal, sodium. You say the nonmetal with an IDE ending. So sodium chloride. So that would be magnesium oxide, barium chloride, aluminum oxide, iron 3 iodide or ferric iodide. Naming acids, it's a little bit different. Remember, acids are always going to have hydrogen at the beginning, and then whatever the anion is, the negative ion is, determines how you name them. If the anion ends in "ide," for example, hydrogen chloride, then you use the "ide" rule, which is hydro blank ic acid. Hydrochloric acid. If the anion ends in "ite," like nitrite, hydrogen nitrite, then it's nitrous acid. That's the "ite" rule. If it ends in "ate," like nitrate right here, hydrogen nitrate, it's nitric acid. So there's the "ide" rule, the "ite" rule, and the "ate" rule. I want to go back one slide right here just to let you know why does this right here not have any subscript or any numbers written down here. Remember, magnesium is +2, oxygen is -2, crisscross applesauce, there would be a 2 here and 2 here, and you can cancel those out or reduce them. Barium is +2, chloride is -1, the 1 comes down here, it's known, you don't have to write it down there. The +2 comes down here, the 2 comes down here. You need two -1s to cancel out that +2. Crisscross applesauce. Aluminum +3, oxygen -2. Iron +3, iodide -1. Crisscross applesauce. All right, covalent compounds. Covalent compounds are two nonmetals, so you have a negative and a negative. They're sharing electrons. You don't have opposite charges attracting. The easiest example of covalent compounds is CO2, both nonmetals. You say the first nonmetal, carbon. You say the second nonmetal with an IDE ending, oxide, but you have to use prefixes. carbon dioxide. Now, if the first nonmetal does not have a subscript, and it's just one, then you do not have to say mono. Notice I didn't say monocarbon dioxide. But if it does have a number there, then you do have to use the prefixes. The prefixes you guys should have memorized. 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 penta, 6 hexa, 7 hepta, 8 octa, 9 nona, and 10 deca. So this would be dinitrogen pentoxide, carbon tetrachloride. Now I threw this one in here because you're going to have to notice that this is not covalent. This is a metal and a nonmetal, so this is ionic, so it's just potassium oxide. This is two nonmetals once again, so it's dinitrogen monoxide. The second one does have a 1, and I have to use that prefix. That is your review on nomenclature.